Good afternoon, ladies and gentlemen, and welcome to the KwaZulu Natal Centre's webinar on cable theft, a manufacturer's perspective. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on your device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. And by default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV, under the KZN Centre playlist. This channel is updated regularly, so ensure you check back as often as possible for new uploads and subscribe. You will find the subscription link in the chat function. Please click on it and join. It's free. A certificate of attendance will be issued a few weeks after this webinar once we have received the CPD validation number from EXA. I'd like to introduce you now to our host for this afternoon. It's Mr. Shepherd Nkosi. He's the chairman of the SAIEE Kwa-Zulu Natal Centre. He holds a Bachelor of Technology degree in Electrical Engineering, a post degree with USQ, University of Southern Queensland in Australia, a post degree in Project Management with the University of Stellenbosch, and is currently completing his master's degree with KZN. He is chairperson of the SAIEE KZN Centre, served as vice president of the Durban University of Technology's advisory board, and is professionally registered with EXA. Over to you, Shepherd.
Thank you, Madam Minks, and a warm welcome to one and all. With all protocols observed, I would like to extend a warm welcome to everyone connected this afternoon. I'm sure we look forward to the presentation. As engineers, as a society, as community, we are affected by the supply. And just before we introduce our keynote speaker for this afternoon, I'm sure from members that are surrounded or in KZN, we are aware of the issues that we currently face with the storm and challenges around KZN, and condolences to the families that have lost their loved ones and all those that are going through all difficulties in that area. And today we have Annie Scholz from Aberdeen, and Annie is a mechanical engineer. He holds a BEng mechanical engineering degree, and that is from Stellenbosch University, and he is also a registered professional engineer with the GCC registration. He is a member of the SAIEE IME and the SAIEE and the SIGRI as well, and the insulated cable and the IEC C20 cable committee. He serves as the current chair to the SABC TC 66 Cable Committee and the chair of the Association of the Electrical Cable Manufacturing, which is those abbreviations there. Would like to extend a warm welcome to Annie. I'm sure we all look forward to his theme this afternoon about cable theft and some solutions with regard to this challenge that we face with. Annie, over to you. I'm not sure if it's my volume, Annie. I cannot hear you on my side.
Is the volume on now? Can you hear me?
Yeah, it is on now. Thank you. Over to you, sir. Thank you.
Thank you, Shepherd, for the introduction, and also thank you to Minks for arranging this session, and for everyone who's attending this afternoon. I'll try and make it as interesting as possible, and to give you an indication or a view of the manufacturer's outlook on cable theft and the solutions that we have considered in the past and are also evaluating for potential future use. So I think without further ado, let me share my presentation.
Perfect.
Okay. All right. Thank you very much. I'm not sure if you can see the screen on the right-hand side. I just want to stop that. Okay. Right. Developments in theft deterrent cables. The topics of discussion is a brief introduction, and to discuss the methods to physically restrain cables, talk about traceability of ownership, discuss the options for, let's say, unattractive conductor materials, and then to also discuss other options that may be considered. I think as an introduction, you know, we are part of this let's say process, and I would not say part of the problem, but we as cable manufacturers certainly are committed to ensure that sabotage of our electrical network and systems are kept to the minimum from whichever way we can do so. And you know, you will see in the presentation that we and other manufacturers as well have tried different alternatives, solutions to try and limit the theft of our product. But we should also see this as a all-encompassing issue, and that socioeconomic problems and issues influence this theft and sabotage of infrastructure also. So we as manufacturers can do what we can do, and I think it's up to all the players, you know, to also do the same in their areas of responsibility. So we are certainly trying to make a difference from our point of view. So what can we as a manufacturer do to try and prevent cable theft? I think the first thing is that we can make available equipment to physically restrain cables and conductors. We know that some of these cables are being pulled out of the ground, cut in sections, and then hooked to a vehicle or pulling device and pulled out. So one can have these systems to restrain the cables that are in ground. Unfortunately, there's no such systems apart from traditional cable cleats to secure cables on racks. So we can also provide unique identification marks in or on the cables and in the conductors, and that is to prove ownership. So that when cables are discovered and these thieves are caught, that we know who the manufacturer is, and we also know who the owner is of this product. We can also design cable types which makes use of alternative, let's call it unattractive conductor materials. Some of these conductor materials are not accepted in the current SANS specifications, most of which are compulsory. So we have had to find ways around that and work with particular customers. But certainly in some cases this has helped the situation. We can provide a visual means to identify anti-theft cables at a glance. So in other words, you know, don't try and steal the anti-theft cable, rather, you know, go somewhere else. And unfortunately, of course, that leaves other low-hanging fruit for the thieves to address. But certainly we can then rule out the false attempts at stealing cables. We can also provide the means to do live monitoring of cables, say via OTDR or acoustic monitoring of cables by putting fiber into the cable or other means of monitoring. And then we can also track cable drums. So in the cases where cable drums get stolen, we are able to also provide RFID technology to assist with that. So just to discuss then the methods of physically restraining cables, I must say this has not been as successful as we had hoped. quite some years ago, Aberdeen, in conjunction with a technology partner, developed the cable guard range of products, which you see in a picture in the center of the screen. And the cost of such a system was around 10% of the cost of the cable, which I think was seen as excessive by customers, and therefore the system never really took off. We had some trial installations, one in particular with Ekurhuleni, but it remained at that level. So unfortunately, this has not really had the effect that we had hoped it might have. And obviously this relates only to cables that are newly installed and not to existing cable installations. There are other systems, like for instance the company Cable Croc, who have a range or had a range of devices which anchor the cables below ground and above ground. From my knowledge, this particular system is also not taken off, potentially due to the cost of the installation of steel components which had to be used in conjunction with the cables. But I think it was potentially a good system to secure cables underground. And then one, of course, had other makeshift methods, like this one on the right bottom, which shows a cable being clamped by two rubber pieces that also prevent, to some extent, the cable being pulled out of the ground if you attach these type of devices at intervals. So I'm not aware of any contractors who are actually using these physical restraining methods. I think where there's a requirement for this, they would rather use concrete to encase the cables, but that of course has a whole host of problems of its own with future maintenance requirements. So traceability, I would say, is the one area where, in essence, the whole industry has implemented this kind of marking, particularly on medium voltage and some of the bigger sizes of low voltage cables. So it provides unique traceability for the cable and for the conductor, depending on the size of the conductors. Here you can see examples of a type which has been introduced into a conductor. This is just a bare conductor. It shows the barcode type and the manufacturer's name, and then also a number. So typically this is the type that's used. It's a white colored type. It's about 4 mm wide, and it provides traceability in terms of the manufacturer and in terms of the type supplier, as well as a code that changes every meter along the distance. Sorry, every 100 millimeters along the length of the cable. So the idea is that if you know the number at one end of the cable as well as at the other end of the cable, then you know all the numbers in between, because this is a sequential code that's applied. You can also scan this barcode to get the number, which makes it fairly easy if you have the right equipment. Here's a picture of a medium voltage cable with water blocking. You see the white is the water blocking, and the inner portion here you can see bits of the barcode. That is the barcoded type which is applied to the conductor. At the moment, the limit is at strand constructions of more than 7 wires. Just purely a physical constraint at this particular point, and all larger sizes can easily be marked with this type. We mark both the cable as well as the conductors, depending on the customer's requirement, and this system gives us very good, let's say, it doesn't interfere with the manufacturing process, because the type codes are only recorded after the manufacturing process has been completed fully, after final testing had been done. You only need to record these codes at that step, and not at the time when you install it into the conductor, which is a huge bonus for manufacturers, because it means that you don't have to trace the components, the conductor components, through the complete manufacturing process. You only have to install and pick them up at the final production process. So the codes are kept in a database, and there's also a SMS query capability where the ownership of these codes can be traced. So only the codes which are allocated to a particular customer are recorded in the database. If we manufacture cables that are not allocated to a particular customer, say a distributor, for instance, where we don't know the final destination or final user of the cable, these codes are not recorded in the database. So there is a SAIEE standard that was developed and published in 2018, which deals with unique conductor and cable marking systems. And this document deals with cable marking guideline aspects, such as the marking technique, marking location, the limitations, the data, and the database requirements. This is quite a generic document, so it doesn't go into the absolute detail of for instance, the tape marking system. But at this particular point, the only solution that is in the market from local cable manufacturers is this tape marking method. So the Cable Association of the South African Cable Association has a document which describes the particular details of this tape marking system in more detail. So alternative metals can be used for electrical conductors. Obviously, we all know aluminium, hard-drawn 1350. So it's a basic aluminium alloy 1350, which we use for conductor stranded conductors in the low voltage and medium voltage space. A number of utilities have actually moved over or started moving over to using aluminium, and we've seen that particularly in independent power producers from overseas have really made use of aluminium cables for wind farms and solar PV farms to quite a great extent. So I think that's also introduced aluminium and made contractors or installers much more comfortable with the usage of aluminium. And I would say it's proven to be quite effective in some applications. If prospective thieves know that this is aluminium they're dealing with, they would tend to leave those cables alone, in our experience, and rather go for copper. Now, obviously, this material is limited to minimum of 16 square millimeter due to creep-related problems. So it doesn't, let's say, provide a solution for controlled cable theft, for instance, in its pure form. So there's still some reluctance or let's say knowledge which is lacking in terms of the use of aluminium. So when customers want to move over or considering it, they need some discussion and understanding of what these changes will entail. But I think it's bound to increase where it's not really being or already being applied, this changeover. Tin copper and galvanized steel, a mix of metal. This application has been implemented in a product we call SAIEE, which is a safer CNE cable as an alternative to EDAC service connection cable. Eskom has been the main driver behind this particular product, and we'll talk a little bit further about that in some of the next slides. So earthing applications also use a mix of metal. In some cases, you might know the Quena product, which is a sort of a braided product making use of tinned copper and galvanized steel, and that has been let's say fairly well accepted in the market. Although for direct burial applications, it's proven to be let's say problematic through bimetallic corrosion. But yeah, there are applications where these cables are also insulated. The SANS 1507 Part 6 standard, which is service cables, has been amended to also include the mixed metal CNE service connection cables at this stage, although not the SNE version. Other alternative metals for electric conductors is copper-clad steel. We've seen quite a bit of this metal being, or conductor being imported into South Africa. It's a composite conductor metal, so and I'll explain a little bit further in the presentation. And it's a similar process to manufacturing of copper-clad aluminium, and it can generally be applied in earthing applications to reduce the value of the scrap metal, because the copper is bonded to the steel inner core, and it cannot really be mechanically separated. So there's quite a number of these applications now which use copper-clad steel in substations and earth mats. The NRS 102 standard has been compiled some years ago, and that sets some of the requirements for these conductor types. Steel is an option, but due to the properties of steel, it's really not found application as electrical conductor in power cables. Of course, it has a very low conductivity relative to copper, about 10%. But potentially these could be used in low power, very low power applications for LED lights, for instance. Aluminium alloy. These 8176 and 8030 alloys have been specially developed in America years ago, and these alloys are used for wiring of premises in the USA. So this addresses the problem with creep in or metal flow, leading to loose connections and odd connections in electrical installations for sizes below 16 square millimeter. And that's definitely an option as alternative to copper for these small sizes. So just a little bit more detail on copper-clad steel earthing. There's a thin layer of copper which is applied over a steel substrate, and this kind of system relies on a metallurgical bond between the two metals, and that's the reason why it can't be separated mechanically. You have to use a chemical process if you were to try and separate the two metals. This is not plating, it's a electrolytic process. It's a mechanical means of applying copper types to a very clean substrate of steel, which or aluminium alloy in the case of CCA. This picture shows aluminium alloy, but the process is exactly the same also for steel. So the input here would be steel and the output would be copper-clad steel. So under high temperature, under high pressure, these copper strips are applied onto a metallurgical clean steel substrate, and it's pressed together and then immediately drawn down to smaller sizes, so that there's a metallurgical bond between the two materials. So the basic properties of these materials is high corrosion resistance, reasonably high electrical ampacity, mechanical robustness, and very limited scrap value. So if scrap of copper-clad steel or copper-clad aluminium is melted together with copper scrap, it can really cause havoc with the scrap dealer or recycler of scrap through the contamination that this would create. So normally or generally the most common conductivity copper-clad steel is a 40% IX, which is 40% of the copper conductivity standard, and where a 500 micrometer thick layer of copper relates to a 100-year life for this metal. So it's good to be installed underground, buried directly as well. There's some pictures of copper-clad steel conductors, and there are quite a number of standards that specify the requirements for these metals. So it's not a, let's say, uncontrolled industry. If you order this material from a reputable manufacturer and supplier, you will find that you're getting the proper quality of metal that you're expecting. So quite well standardized, particularly in the American environment. So copper-clad steel earthing systems, the fault rating depends on the allowable temperature rise. Of course, when you calculate fault rating, it relates to the time of the fault, the time duration. It relates to the start and end temperature, and it also relates to the properties of the material and the size, in essence the resistance of the product. So, but it also depends on the type of connection that is made. So the best connection really that will take you up to the melting point of copper basically would be a welded connection, so like an exothermic weld connection like you see here. But you can also obviously get bolted or crimp connections, but one would have to consider that the fault rating of those conductors would be lower than for an exothermic weld connection. So one would need to consider this when applying these conductors, that if such an earth conductor is right next to another cable, like in this picture for instance, having this conductor go up to 1,000 degrees is not going to be very good for the cable that it's installed next to. And of course, as we spoke earlier, corrosion, bimetallic corrosion is a problem with these type of conductors as well, when you're talking about bimetallics. But for copper-clad steel, corrosion is not an issue. It's recommended that the ends are protected where the steel is exposed, and that a type of lug that doesn't allow water to enter here, and anti oxide paste is used when you're terminating these type of conductors. So 135 aluminium as a replacement for copper cables. Aluminium is of course significantly cheaper than copper cables. Aluminium cables are less likely to be stolen due to the lower scrap value. Aluminium cables are lighter. They are not really suitable where corrosion is likely. But having said that, we know that a big utility such as City of Cape Town have been using aluminium for a very, very long time. And even though it's many of the installations they are located close to the sea or subject to corrosive environment, there are ways of getting around that. So certainly not a showstopper. So 1350 is not used for conductor sizes smaller than 16 square. We know that some customers are still unsure of the risks, and it's just a question of communicating and pointing out what installation requirements there are for these kind of cables to address that issue. The increased cable size of copper equivalent aluminium cables can cause issues. Sometimes you have to increase the size to of a replacement cable for copper up to 2 sizes larger, and that creates issues with bending radiuses when you want to install in switchgear and so on. So it can become a issue where you have tight spaces in which to install these cables. You need special types of connectors, mostly either bimetallic connectors to connect to let's say copper bus bar or different metal type, or aluminium alloy, and often the mechanical type connectors are used for this type of application, which also has anti-corrosive paste inside these connectors. So the solution is there to apply aluminium. We know that in the mining environment, aluminium cables are not allowed to be used, particularly in fiery mines, due to the risk of a flash and explosion. Class 5 flexible aluminium conductors are not generally in use, although we have made such cables and are supplying to one of our mining customers for surface mining operations, and it's worked very well. And surprisingly, these aluminium flexible conductors have quite a high fatigue limit, so we've not really seen any significant issues with using these types of flexible aluminium cables for trailing cable applications. In our case, it was up to 33 kV. There's no defined fatigue limit for aluminium in general, so the fatigue performance is quite good generally, particularly if you're using annealed aluminium. If you're using hard-drawn aluminium, it is definitely a problem, because any little nick or stress raiser on the surface of the wire will cause early breakage. So hard-drawn aluminium, we all know from aluminium wire armoring, can break very easily. But when you have annealed aluminium, and particularly the alloys of the 8000 series, that is not the case. So 1350 is not suitable for use under conditions of vibration due to this fact. We mentioned earlier the SAIEE service connection cable that was developed together with Eskom. We make use of mixed metals to use that general term. So inside of the cable construction are wires of tin copper and galvanized steel, and this serves as a deterrent, because the mix of metals are not that easy to distinguish. Some customers even refer to it as aluminium cable. You can see in this example, this photograph shows a cable with these mixed metals, and it has a look, let's say, similar to either galvanized steel or aluminium conductors, particularly for people who are not used to the look of these metals. So it certainly doesn't look like copper, and the mix of metals presents a problem for the thief and the scrap merchant to separate. And it's also not very clear what exactly the metals are that the thief would be bringing in for recycling. So Eskom has found this to be a significant help for them because of this reduced scrap value, and they've certainly seen that these cables have reduced the incidence of theft, particularly in new installations which make use of these type of cables. Eskom doesn't use this yellow version, although one of the other metros or municipalities actually have used the yellow version, which is a indication of, let's say, this cable being different to the standard EDAC cable, and that's also helped those particular municipalities to combat theft. We would generally say that this cable is not intended for direct burial application, because bimetallic corrosion will potentially be a problem if water is allowed to enter the cable through a damaged sheath or at the end of the cable. Some background of this: Eskom started the work group in 2011, and their aim was to not only reduce theft but to also have safety improvement. They had a 60 amp requirement. Developments followed where 6 square and a non-standard 8 square millimeter cable was developed. Evaluation and testing occurred, and I think this is an old figure, 3 million meters. It's probably near to 20 million meters that have been supplied already at this stage, and Eskom has in essence standardized on this type of cable. The standards that are applicable is the Eskom distribution specification listed here, and also the SANS 1507 Part 6 specification, which had been amended. A number of evaluations had been done for current verification, UV testing, a nail test to test for short circuit overcurrent capability and burning of wires, creating an open circuit. Termination evaluations for resistance were done on site at the Eskom site. Corrosion testing was done, and there are now a number of reference installations for these kind of cables. So quite widespread at this stage. If we move on to the alternative conductor material of copper-clad aluminium, I must say that this has also not been successful, and I would say mainly to the extent that manufacturers were not comfortable with the problems associated with this particular conductor and the cables. It's manufactured in a similar way, or in the same way as copper-clad steel is manufactured, and you also need high purity aluminium and high purity copper, because you need this metallurgical bond, which is created in the same way as you do for the copper-clad steel. These metals cannot be separated. Can only be separated if you make a poor quality product, so they're not intended to be a loose cladding onto the aluminium. It's supposed to have a solid bond. This conductor also have a very low scrap value due to the dissimilar metals. It is seen to be environmentally unfriendly in that there's very little one can do with this metal. You can recycle, and there are some alloys which can be made with aluminium and copper, but those are very specialized alloys, so it will probably end up in a scrap bin somewhere. So it is really problematic. It's also difficult to manufacture and control within the manufacturing process. These conductors break easily. They also stretch easily, and prone to high scrap rates in the manufacturing process. The NRS standard was developed, 110, which is the low voltage utility power and control cables with copper-clad aluminium conductors for theft prevention. So this was published, I would say about 3 years ago, and also it hasn't seen the uptake that it was thought to have going to have. The main interested parties were City Power and also Eskom, and although Eskom had put out a request for information, none of the local manufacturers actually offered cable containing these copper-clad aluminium conductors for the reasons that I mentioned. It's the metal is requirements for this conductor metal is also well described in this ASTM standard B566, and all these conductors are imported. But currently I'm not aware of any cable that is physically made with these conductors and imported in this country, except for non-compliant cables, wiring cables in particular, flat twin and earth, which is brought in from overseas. We've seen imports from China where these cables come in and on the surface look to be compliant, but if you look at resistance values and current carrying capacities, these cables are way below the standard and can lead to fires and so on. So obviously, if one were to make a power cable from these type of conductors, you would need to increase the size in a very similar ratio to the increase that would be required in size if you were to change from copper to aluminium. So just briefly, you can see the different or the comparison here in the table between copper-clad aluminium, or 10% by volume, and aluminium. Specific gravity, CCA is much closer to aluminium than to copper. Resistivity is and conductivity is roughly the same as aluminium, as you can see here. Copper is 100% and CCA is 63 and aluminium 61%. The weight as a percentage of the copper is low for CCA, 27%, that of copper, and the volume of copper is only 10%, as defined by the 10% name that's given to this particular version. You also get a 15%, but I would say 10% is probably the most used. Tensile strength quite a bit lower than copper. Coefficient of expansion is also significantly different, and of course this is where some of the problems come in that you have between, let's say, aluminium and copper, is that the rate of expansion is different, and you get loosening of connections when you're using small sizes of aluminium. But this has really been addressed by copper-clad aluminium and the use of 8000 series alloys within these type of conductors. Okay, in terms of the application for aluminium alloys, there's specialized cables like center pivot cables used in irrigation where there's high risk of theft. You can see a sample here of a cable which makes use of different sizes of aluminium alloy. This has not been widely accepted, I must say, and the aluminium itself is often, where it's used here to make cable, the aluminium is imported into the country and is not manufactured locally as an alloy. You can see the designation of the 8030 and 8176 alloys here, with the properties that they have. IX is for these products is 61, which is basically the same as aluminium, and fairly low elongation, 10%. Yeah, so if you're interested, these are the properties of those two grades of alloy that are being used. We've made some multi-core cables which we've supplied to Joburg Roads Agency. This is an example of one of those multi-core cables that we've manufactured, and they are used for traffic signals where there's quite a high risk of theft and also a high cost to repair. JRA quote between 100 and 250,000 rand to replace the cables and fix the damaged intersection where cable theft has taken place. There's also the question of distribution substation vandalism. So Eskom has also started looking at this and are busy evaluating it in the field. So just as a illustration, 27 core 2.5 aluminium alloy has a current rating of just over 8 amps, and the equivalent copper cable has a current rating of about 13.6 amps. So significant difference. So if one required this copper cable current rating, you would need to increase the size of your multi-core, which obviously can result in some problems with sizes and bending and so on, particularly when you get to the higher core count of some of these cables. But it is definitely a solution for where theft occurs. So just some pictures of one of the installations that was done using this type of cable at Joburg Roads Agency. This intersection was completed, and to the best of my knowledge, there was never any theft attempt following this incident, where they've had numerous attempts in the past with copper cables. So once again, the aluminium alloy standards are well documented in the ASTM standards, but the USA wiring code, so to speak, the NEC, also allows these small conductors to be used for wiring applications. And although the USA had very bad experiences in the earlier years with aluminium, it was with standard 1350 aluminium where creep caused major problems for them, and many fires that had been caused through the use of standard aluminium for these small sizes. But it's well accepted now that these 8000 alloys solves that problem. So the wiring code allows the use of these aluminium conductors without, let's say, any special precautions except for the terminations that are required. If we move on to live monitoring of cables, we experimented with some alternative configurations of cables, in essence providing a blown fiber capability which can be incorporated into these cables. The idea is that you can install a cable with this facility and only at a later time use the installed facility to blow in fibers, and then to either monitor for heat or for tampering by these systems. You can also install fiber to the home in low voltage applications. So it has a number of potential applications. Unfortunately, the equipment that's used for monitoring of these cables for theft or tampering is very expensive still. So it's only really for perimeter protection in large complexes, that this would be feasible at this stage, or where you're already using fiber and monitoring systems to monitor let's say high risk, high reliability type of installations. Signage and identification of theft deterrent cables. So it's important that you identify cables which are designated or intended to be anti-theft, and therefore in some of these cables we've used different color sheaves, like these two examples. We've considered the ribs for the safer DAC type service connection cables. Some users have even attempted to spray paint conductors, and then of course notices to warn off potential thieves in that the scrap value of these type of cables or conductors is very low, and that they shouldn't attempt to steal it. For the copper-clad steel conductors that are being imported for earthing, there's also a method by which the outer surface of these conductors are colored or discolored to let's say make it look less like copper, and therefore warn thieves that this is something different. We're busy doing evaluation at the moment on soil stabilizing treatment. This, you'll see the name Terralock appear here. I'm not aware of any other companies that do this kind of soil stabilization, but our early tests, you can see some of the test objects that were made here, cables that had a high concentration of the soil treatment agent, which contains some bitumen but also a hardening agent, and we age these samples in ovens like we normally age cables to assess whether they age in the way that you anticipate, and that the materials around the cable sheath do not influence the cable materials in a significant way. So in essence, testing for compatibility, and we found that particularly white stripe cables in this mixture was influenced fairly severely, but we're doing further tests to confirm. So in essence, the idea is that you use backfill soil, you place that as a bedding underneath the cables once you've conditioned the soil with this material, and then you backfill and compact in a normal way, and then after some time this material hardens, so you have to use mechanical tools to remove this material from the cables, and that stops cables from being pulled out of the ground, because the cables adhere to this treated soil, and also digging out the cables is a very cumbersome process for a thief who wants to quickly get to the cables and remove them. One of the main concerns from potential users is that this will make it quite difficult for maintenance. That if you have to open up a cable run for the fixing of faults and so on, that this removal might be just too much. You know, so I think there's got to be some work done in this area to show users that it is not as cumbersome to open up these cables as they might think. So still some development work being carried out. The initial indications of cost is also about 10% of the cable cost. Now, I don't know whether this reflects a undue amount of profit, or whether that is a reflection of the real cost, we'll have to see. So we haven't concluded our testing, and as soon as we have more information available, we'll make that known. The last one here, last slide, I think is cable drum tracking. It's a radio frequency identification device which gets installed in the drums. It looks like this. Obviously, once the cable is off the drum, there's no way of actually tracing that the cable. You know, there's no RFID in the cable, so for a standalone cable, the solution is not suitable. We've implemented this some years ago in our own manufacturing setup, and we had marketed this to customers, but really after running some trials and so on, customers have decided that this is not really worth it, and that it would help them to some extent with stock control, but not really with theft. So we've basically abandoned this system for anti-theft purposes at this point. So not a good story, but I think stock control really showed that it has benefit, particularly for a manufacturer in their own process. Okay, I think that is the end of my presentation. Thank you very much.
Thank you. Thank you so much, Annie, for the detailed information that you've shared with us this afternoon. And I'm sure the members connected, they really appreciated the information that you've shared. And I also had one or two questions, but I see there's quite a number of questions also that we've received from the attendees. And I think it's one of my questions, I think you've just covered it. It was more on the thermal resistivity. If there's also these hydrocarbon binders, the one that they use to create some soil, solid, the bonding of the soil, and if that doesn't affect the thermal resistivity, and some of your the issue with thermal heat for your cable. But maybe let me just go through one or two questions. We've got about 6 questions. Let me go through one or two questions. Maybe we can go through the response and take the few. There's a question from Franz. He wants to know, what about the use of metal alloys for conductors such as doped with silver? You might have touched maybe partly on this one. And then the next one coming from Marius, he wants to know if alternative metals are used to reduce the scrap price. Does this reduce the new procurement price as well? So as there's an effort to reduce or provide alternative metal, does that mean then the price will also be reduced? And another one from is it Mikhail? The question there, what are the vibration limitations of aluminium cables for use in mobile application like vehicle? So maybe we can take these few questions for now, and yeah, and I think there's few also that's I can say it's coming. Thanks, Annie.
Thank you, Shepard, and the attendees for those questions. Yeah, the soil thermal resistivity is not affected by the addition of this particular stabilizing agent. The addition is between 1 and 2% by volume, and it can go up to about 5%. but the tests that have been done by the soil laboratory, which was engaged by the supplier. Remember, this is not a product that's supplied by Aberdare. Has shown that the thermal resistivity is not affected at those levels. If we go to the if we go to France, he asked about the use of metal alloys doped with other materials. I think if you look at copper, for instance, the electrical conductivity is significantly affected by contaminants. So what the industry normally uses is, just as background, is ETP copper, electrolytic tough pitch copper, and that has a IX international accepted copper standard value of 100%. But there are also oxygen-free copper rods available, designated by the letters OF, oxygen-free. And although the levels of contamination between those two types of copper are the same, the only difference is that the amount of oxygen is higher in the ETP version, and just the addition of oxygen at slight levels in that metal makes a significant difference. So the IX of oxygen-free copper can go up to about 103%. So it could make a 3% difference, just the oxygen. So copper and most metals are very susceptible to contaminants, and so is a good is a good conductor of electricity. So I would say it probably would not make a massive difference to the copper conductivity, but it's also, of course, quite an expensive metal, and one would have to see what the what the benefits are from doing that. So it might not have the benefit that one would think it might have. Yeah, and if the price of the scrap metal is not significantly reduced, which I believe won't be the case, then why pay a higher price for the raw material? And these kind of alloys are also not available, let's say, off the shelf, to the extent that the copper, the high purity coppers, are available in the market for manufacturers to use. Okay, then I think, is it Mani that asked the question about the use of alternative metals and the possible reduction in new prices. So I think generally, if you move out of the mainstream and you're using alternative materials like Copper-Clad aluminium or Copper-Clad steel or aluminium alloys, these, or a mix of metal in the conductors, these tend to increase the price of the final product. Partly because the metals are more expensive. You're making something, let's say, out of the ordinary, and it's mostly imported, these type of metals, or you have additional processes for tinning, conductor, and so on. So I would say, without a doubt, these things are more expensive generally than their copper counterparts, except for aluminium. If you make the change from copper to aluminium cables, there's a saving, definitely. Michael asked about the vibration limitations of aluminium. I think standard 1350 aluminium, I would say, don't don't use that material in installations where there's known to be vibrations. You know, as I mentioned, aluminium doesn't have a defined, aluminium 1350 in particular doesn't have a defined fatigue limit. So it's not as if you can say, I'm going to apply this stress to the conductor. I'm going to apply this number of vibrations and amplitudes to the conductor, and it's going to fail at a predicted level. It's not really the case with aluminium, as you might have with copper or other materials. That level is not defined. So you can have vibration-induced fatigue and breakages even at low levels of vibration. So one should be careful with the use of aluminium where there's vibration, known vibration present.
Yeah.
Rather eliminate the source or use copper.
No, great. Thanks. Thanks.
Those are all the questions. Are they?
Yeah, there's one or two, and I also like the initiative, the one that includes fiber. I mean, it's a very good partnership between the electrical and the ICT department. I mean, from the municipality side, where they just buy one feed and they use the very same cable to maybe provide fiber for residential. I think it's a very good one, and I think also, if you know your end-to-end points immediately when there's disconnect, meaning that people are trying to steal your main supply, that will automatically cut off fiber. Maybe that's another solution going forward. There's one or two questions there, also there's one from Mark. I think he wants to know about the bending radius restrictions on your CCA. And Mikhail, again, there's another question. Are there ways of automatic severing of cables if they are pulled beyond a specific distance, that is 20 to 50 meters? I think the other one was, okay, it's more a comment from one member who would like us to present, at City Power. Yeah, I think these are the questions that we have. Any thanks? Maybe the last one or the last two. Thank you.
Okay. Thank you for those questions. Yeah, I agree that I think fiber, the facility to pull in fiber at a later stage is a really nice feature. You know, it opens up so many doors, particularly in medium voltage reticulation and in low voltage underground reticulation. That feature is available for future use, and yeah, it is certainly something to consider. Then Mark asked about the bending radius. Normally the bending radius is governed by the construction of the cable. You know, whether it's armored, unarmored, whether it uses paper insulation, whether it uses PVC or XLP insulation, and in some cases the conductor obviously has an influence as well, particularly when we look at class 5, which is a finely stranded conductors that are used in small cables like cap tie and so on, and submersible pump cables, trailing cables and the like, but very specifically also used with the mining cables, elastomeric mining cables. So for these cables that require to be flexible, the conductor itself needs to be a class 5 in most cases, and also the insulation material should be, and the sheath should be of such a nature that it is flexible and that it can withstand the bending, either continuous bending or once-off bending that will be applied to these cables. So it's a combination of factors. For some of these cables we could go down to about 5 times the diameter, but for the larger cables, 20 times the diameter is about the benchmark. The issue with these kind of cables that one would use aluminium or potentially CCA in would be fixed installation cables, and for those cables the defining criteria would be the insulation, that as you bend the cable you don't want the insulation to be damaged from the pressure exerted by the layers above, whether it's copper tapes or copper wire screening or armoring that pushes, let's say, exerts pressure on the bottom layers, and there would be the concern, particularly if you consider, say, XRP, which has a expansion coefficient about 10 times that of copper. If it expands and there's a restriction over that insulation in the form of copper wires or tapes or armoring, then you run the risk of pressing into the insulation, and over time with load cycling, even damaging the insulation. So just changing the conductor from copper to copper-clad aluminium or copper to aluminium doesn't really affect the bending radius of the cable. That said, I think the bending radiuses that we as manufacturers quote are often conservative, but one has to realize that it's an expensive asset and that these cables have to be run for 30 years plus, and you don't want a unnecessary tight bend to influence the life of the cable. So then Michaela, I think it's Michaela, asked a question about automatic severance of a cable once it's pulled by 20 to 50 meters. If I understand the question correctly, the question is really whether one can build in, let's say, a fail mechanism into the cable that allows only a certain amount of putting tension on the cable, and then the cable breaks. I think one has to balance the fact that you need a robust cable for pulling into installations, and you know, the methods that are used for installing of cables, which puts tension on the cable, and this let's say potential requirement to have a cable break when there's too much of a force on it. I don't think that is a solution. You know, by the time somebody pulls the cable, he's already cut it at more than one position, and you've already, let's say, destroyed that feeder to some extent. Whether he now gets away with a cable or you know, 100 meters of cable or 50 meters of cable, maybe that's not that important for the utility. So in essence, if you put a mechanical restraining device onto the cable and you clamp it in position, that's exactly actually what would happen is the cable would either break or the pulling device would stall, and you wouldn't be able to pull the cable any you know, further than a certain distance. So I would say mechanical restraining devices or treatment of soil might be options to address that particular method of theft.
No, thank you so much, Annie. I think the last one is more a comment, where the proposal is also to use power lines for communication, and to explore that. I think the suggestion is that would be cheaper, but obviously, yeah, the fiber option that comes with the cable, it's also addressing the theft issue, but it's like killing two birds with one stone. On the other side, if there's a need for fiber and you can mix your fiber with your normal electric line. But I think the last one was more a comment than a question. And would like to thank you so much, Annie, for this detailed information, and with the number of questions that we've received from the audience, It just confirms one thing, that your presentation was well received. And would like to thank also our attendees. We've got a number of webinars coming in the next few months, and we encourage you to check our SAIEE.org webpage for the next scheduled webinars. Thank you so much. I would like to hand over to Ming.
Thank you, Shepherd. Thank you for joining us. Ladies and gentlemen, thank you. This webinar was very informative, and thank you very much to Mr. Henny Skolts for his presentation. Let's hope that we can make heed with all the cable thefts in our country. I just hope that when we do change the product, it's not copper cables anymore, maybe aluminium, that there's not a question for aluminium that replaces the copper. But thank you very much for this, ladies and gentlemen. And please watch out in your emails, the email that you're registered to attend this webinar for your CPD, your certificate of attendance with a CPD validation within the next couple of weeks. Thank you very much and good night.